Unsiloed podcast is produced by University FM, elevating the stories of your institution.
Welcome to Unsiloed. This is Greg LeBlanc, and I'm here today with Eric Siegel, who is the founder of Gooder AI. That's your new startup. But also, I know you as the founder of Predictive Analytics World, which is now Machine Learning Week, and also the author of a couple books. The most recent book is called The AI Playbook, Mastering the Rare Art of Machine Learning Deployment. And the previous book was called Predictive Analytics. Okay, what was the subtitle? The Power to Predict Who Will Click, Buy, Lie, and Die. Welcome, Eric.
Thanks, Greg. It's great to be here.
Well, look, I remember going to that predictive analytics world back, I guess, a decade ago or so. And, I've been teaching stats forever. I mean, I was the stats teaching assistant at Wharton for like 4 years. And then I was asked to create the core stats course here at the Berkeley Haas School. And it was right around that time when I got exposed to what you were doing and really started getting fascinated with all of the different applications of machine learning. And that's when I went to my dean and I said, hey, we need to do this, right? We need to have courses in this stuff in the business school, which we didn't really have at the time. And I think part of your life journey is kind of maps well this kind of migration of data science from CS departments, from stats departments over into business schools. And you were originally teaching in Columbia, right? Was it the CS department? And then you actually did a little cameo at the Darden School, teaching in the business school. And I think if you look at your books, I mean, most of what you're trying to convey in your books is this notion that if all you know is data science, if all you know is the technical stuff, it's going to be very, very difficult to make an impact. So I guess maybe the first place I'd start is, tell me a bit about your journey. Like, why did you decide to bail out of academia and try your hand at consulting? And then when you did that, like, what gave you the inspiration to, I guess, become an educator through these conferences and newsletters and so forth?
Yeah, I mean, that's a great question. Why did I leave academia just to continue to be an educator outside of academia? Well, basically, I left academia because I wanted to see these models get deployed, right? I want to see this technology actually being put to real use and helping, improve organizational functions and delivering value in that way, in a real way. And that was what fascinated me the most. And at first, so I kind of struck out on my own in 2003, and I've been an independent consultant until then. Well, until about a year ago now, as the co-founder of Gooder AI that you mentioned, the startup. And when I did in 2003, all of a sudden I was having these meetings. I'm like, machine learning, blah, 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 blah. And their eyes would glaze over, right? So that term wasn't in the business world yet. We switched to predictive analytics, which was a new term at the time, really. I thought a lot better than the term data mining. And it started to catch hold. And I was like, oh, maybe there's a light at the end of the tunnel and there's a glimmer of hope and people are going to start to get it and understand that numbers matter and that this is what it means to be data driven. This is what it means to improve all your existing large scale operations with prediction. And prediction is the most actionable thing you get from data. And the way you get it is with machine learning. It learns from data to predict. That's basically what it is. So, will the world wake up to this? Are they going to forever see it as arcane? What does that mean? So be careful what you wish for, because flash forward to now and everyone's all over this stuff in a way that's overzealous, right? We fetishize the core technology as the most awesome thing. We're more excited about the rocket science than the actual launch of the rocket. That is getting it deployed, getting into action, making a difference in terms of actual business operations. And we're kind of stuck there. Most new machine learning projects fail to reach deployment. So still, there's a skill gap. Still, there's a kind of data literacy that's greatly needed across the non-data science community. But it's not foreboding once you actually dip your toe in. As a business stakeholder, you got to get your hands dirty or your feet will get cold and you won't get to deployment. But that dirty hand stuff is actually, it's only semi-technical. It's totally accessible. And that's the topic of my new book, which, and the theme here is that if you ramp up on a semi-technical understanding, which really just comes down to what's predicted, how well, and what's done about it, with some degree of detail and some dealing with arithmetic in the second of those three, which is how good is it, how well does it work, how well does it predict, and what kind of business will it, what kind of business value will it capture. But by getting involved in details on those things, then you are in a position to actually help the project in a much needed way. You can participate, deeply collaborate with the data scientists end to end across the project so that it'll actually get deployed, it'll get integrated, it'll get implemented, it'll go to production. It'll actually change existing operations. You can't improve operations, obviously, without changing them. They need to be changed with these predictions, with these predictive probabilities, which is ultimately what's delivered by machine learning. So that's sort of the soapbox I'm standing on these days. Let's ramp up on that semi-technical understanding.
Well, look, I mean, did you think that 20 years ago that you would still need to write a book like this in 2023, 2024, right? I mean, because, you know, in the AI Playbook, I mean, you're not spending a lot of time discussing brand new technologies. I mean, you know, Gen AI features very lightly in the book. I mean, you're talking about decision trees, you know, you're talking about, right, logistic regret. I mean, just like the stuff, those algorithms have been around since, you know, before you and I were born, right? And yet there's still this enormous need for organizations to incorporate these methods. I mean, I think it was around the time of your when you left academia, that was really the Moneyball era, right? You know, and I remember, you know, when that movie came out, it was like, okay, everybody's going to see the light, everybody's going to start doing this, and by now it should just be, you know, hygienic. It should just be baseline. It's like using Excel, but it's not. I mean, why do we still need to kind of bang the drum?
So Moneyball, you'd think that maybe Moneyball could be the solution, right? Because it glamorizes, for once and for all, finally, that beautiful union between the beauty and the geek, right? Between Brad Pitt and Jonah Hill in the movie version. And you can guess which of those actors plays the data scientist. But that's the union that generally is missing, and why we don't get to deployment. The actual deep collaboration between the number cruncher, the quant, the machine learning expert, and the stakeholder, the person in charge of operations, meant to be improved. And of course, in the case of Moneyball, the operations are about how the baseball team, the Oakland A's, which by the end of the story has done much better than anybody expected, given the low budget of that movie. Given the low budget of that baseball team. I think the movie had a pretty high budget for that kind of thing. Right. So here you have this high budget, very popular movie, very enjoyable, and saying, look, we can once and for all bridge that gap. But the movie's the epitome, and so is the book, of glossing over the math. So it says that this has to be done, but doesn't actually do it, right? So it's a good step in the right direction, but the doing of it is to actually make this idea of learning from data to predict. And when I say predict, we don't have a magic crystal ball, right? So the next best thing than a super high confident prediction, this person will buy, this one won't, this transaction is fraudulent, this one isn't. The next best thing from sort of unrealistic, super high confident predictions on every occasion is a number between 0 and 100, saying how likely is it to have that outcome or behavior. And that number turns out to be really, really valuable for improving operations. So yeah, everyone knows what algebra is. People may not be that excited about algebra. They might not feel like they're really good at it, but they know the basic idea. You have variables like X that could have a value, whatever, right? We need at least the same familiarity and fluency with the idea of learning from data to predict, with what machine learning is doing. It's much more interesting, fascinating. Look, machine learning is the coolest, most potent, exciting kind of technology and science. It's the best of STEM, right? The idea that it can learn automatically from a limited number of examples, historical examples, for example, where you already know the outcome or behavior, which customer did or didn't cancel, which transaction did or didn't turn out to be fraudulent, right? You may have a lot, you could have, in some cases, millions and millions of examples from which to learn, where you already know the outcome, and those are each a learning case. But still, the amount of data that you're learning from is very, very limited compared to the number of possible cases you could encounter in the future. There's just sort of an unwieldy number of combinations. So that's the sort of technical challenge. What does it mean to learn, to analyze that historical information and to find patterns or formulas that then pan out, that work, that turn out to apply well and consistently with new unforeseen cases that have never before been encountered? That's a formal definition of the concept learn. And yes, we can do it. We have succeeded. And that's incredibly cool. So first of all, why isn't this part of normal curricula in high school? But second of all, without that understanding, this technology sits on the shelf. It's like a magic crystal ball, if you want to use that as a metaphor, even though, again, it's not highly confident prediction like that, collecting dust because it doesn't actually get acted on. So that getting it actually deployed depends on the stakeholders, in addition to data scientists, having that concrete idea of what's this thing exactly predicting, exactly how well does it predict, not magic crystal ball, and yet still potentially quite valuable if you act on it. And that's the third thing, which is what's done about each of those individual predictions. How do you use them in a concrete, simple, straightforward way to decide who gets contacted, which transaction gets audited, which site gets drilled for oil, which satellite gets investigated as maybe running out of battery, any and all the large scale, which train wheel gets inspected as potentially failing, any and all the large scale operations that we need to so desperately improve, right? Prediction is the holy grail for doing that. So this isn't the rocket science part, it's how to steer the rocket. And if we don't have a sense of how to stress test and operate the rocket, it's not going to get launched. So, a rocket scientist may very well be more excited about the rocket science than the actual launch. They might say, hey, this is fun stuff. I love the math. I love the engineering. And, maybe we'll launch the rocket next year or someday. Who cares? I love this science. That's fine. But as a society and as a business, right, that's not enough. We need to actually act on it.
Well, I've taught in business school and engineering school, and there is sort of an almost unbridgeable divide sometimes between these different groups. And I think you quoted somebody in the book that said that a data scientist would rather solve AGI than go and talk to a customer. And so I remember we created this class about a decade ago where we had data scientists and MBAs. And then we had a third group of kind of data engineers, and we made them work on projects. And it was funny, like at the beginning of the class, they were like boys and girls at a high school dance. They didn't know how to talk to each other. It was really, but then over time they learned to talk to each other. And I think at your predictive, at your conferences, you would have some data scientists and then you'd have some business folks. I mean, is it easier to teach business people the rudiments of the tech, or is it easier to teach the tech people kind of the rudiments of business? Which is the easier?
I mean, that's kind of like asking whether it's easier to get the boys to talk to the girls or vice versa. And that's above my pay grade, but they do need to start talking or the human race will stop procreating. So it's very vital. So you said it feels like it's unbridgeable divide, and it does feel that way sometimes, but I adamantly believe it's totally bridgeable. So it's sort of like going back to, like when I started out as a consultant in 2003, and I'm going out to the business world, I'm like, hey, you should be using this machine learning stuff. And at the time, it felt like they were unexcitable, right? Like, how are you going to get these people to see this isn't arcane? This is extremely actionable, and this is the ultimate manifestation of the basic idea of driving operations with data. So, but at the time, it kind of felt like, geez, are they now? They're too excited, right? Everyone's sort of like, if you're using this technology, you're intrinsically creating something valuable, which is not true. It's not intrinsically valuable. It's only valuable if you act on it, if you implement it. And there's the rub. So now it's about this divide. Um, and it's sort of a cultural thing. There's a bunch of inertia, but basically you could sort of think of it as getting incentives right, and they're going to come, right? Right now, if we're kind of running on fumes of hype where these failed projects that don't actually achieve deployment and therefore don't capture any value are failures, and that failure gets swept under the rug, and people have developed great skill in sweeping failures under the rug. That's helped in great deal because of the AI hype, but that's not sustainable. So there are incentives down the line, right? The executives are getting wise of these lack of returns, and it's not good enough just to use the best technology. You have to actually act on its output, right? You have to implement it, use it in that respect.
Mm-hmm.
So, but there's sort of, you can see it right now as there's this sort of short-term it's sort of self-serving on both sides of the divide to have that divide. On the data scientist side, right, by seeing everything as arcane, even the semi-technical, just sort of the basics of how do you steer this rocket in the first place, once it's been built, they get to retain their stat, or I'm a data scientist, we get to retain our status as sort of, having ownership of everything related to a machine learning project. And we get to sort of have this authority and therefore value. And then on the stakeholder side, they get to benefit by feeling like, oh, we don't have to deal with any details at all. Anything that's involved with some details, and this is the detail I'm talking about, what's predicted, how well, what's done about it, a bit of arithmetic, some concrete details, connecting the hose to the faucet so the outputted probability actually changes in operation. It's not the rocket science part, but it's what it takes to actually implement this stuff. And what it takes isn't just physically connecting the hose to the faucet, but an understanding of exactly that's going to entail across the enterprise so that those stakeholders are also in on it from the beginning and won't get cold feet, right? So there may be some short-term benefits, but the fumes are going to run out. And I think this divide that feels so unbridgeable, a few years from now, all of a sudden, whoop, we can't do it that way anymore. I mean, that's got to be where we're headed.
Well, you always hear these statistics about, 90% of these data science deployments fail, right? Or, actually, you hear this about everything, right? So it's 90% of the digital transformation initiatives fail. And so all of the consulting firms will trot out these numbers. And, I think part of what you're trying to do is reduce the failure rate. But I always wonder if it's a constant, like as we get better, we just we get more ambitious and the failure rate stays the same. I mean, what are the main reasons for these failures? I mean, I think you have all the various steps of this biz ML process, and any one of them could be a failure point, I suppose. But what do you think are the sort of the biggest reasons why these initiatives fail? And does it depend on who's actually launching the initiative? I mean, if the initiative comes from the business side, is it more likely to succeed than if it comes from sort of the data science side? I mean, it seems like the data scientists, they have these solutions, but they don't really know what the problems are. The business people are more likely to start with the problem, and I think that means it's more likely to succeed. But is it more likely to succeed depending on who's in charge?
Yeah, I mean, if it kind of starts from the business side, I think broadly that probably increases the chance of it getting actually deployed and implemented in that way. So, but basically the root cause is that disconnect. And if the stakeholders don't get their hands dirty, their feet will get cold, right? They're delivered this, hey, the data scientist says, we're ready to deploy this model. And then it turns out that the stakeholder wasn't really ready to receive the throw and catch the ball, right? They weren't fully prepared to change what are the largest scale, highest stakes operations, therefore the highest opportunity to gain a bottom line impact by improving. But there's risk, there's change, it involves probabilities, right, which are not hard to understand, but are outside the purview of what stakeholders have sort of been trained to think about and get comfortable with. But yeah, now plenty of these projects succeed, even if it's a minority. There's so many projects, right? Even a small portion of a lot is still a lot. And I've been involved in a couple rounds of industry research. So most recently, although more than a year ago, with Rexer Analytics does one of the main data scientist surveys. So this is from the data scientist's perspective. We found only 22% of data scientists say that their initiatives with machine learning meant to create a new capability usually deploy. So we don't have an absolute number of like, it's only 10% that deploy or only 20%, but only the majority of data scientists say that they usually don't deploy, right? So it's a little bit funny. Suffice it to say, most of these projects don't deploy. And the same thing comes from the business side stakeholders as well. IBM more recently came out with industry research showing that AI's average returns are essentially zero. They're lower than the cost of capital. That is, of how much would it cost to just to invest that money. So the problem is that we need to get everybody on the same page. We need to get those data scientists to speak in business terms, and for the business people to be interested in some of those concrete details. You know, business people might say, hey, look, I don't need to get involved in details. I don't need to pop the hood of my car to drive it, right? I don't need to know how the engine works. And that's totally true. Like, I personally have no idea, right? I know the general principles of internal combustion, but I don't know where the spark plugs are. But I'm totally an expert at driving. I know momentum, friction, the rules of the road, how the car operates, and the mutual expectations of drivers. The analogy holds. To drive a machine learning project successfully through to deployment, you need analogously those kinds of semi-technical understanding of what it means to run the project so that it will succeed.
Yeah, no, I think that's a really important point. And I love that analogy of driving a car. I've used similar analogies in the past, you know, because when you're teaching MBAs in particular, that's always the question, right? How much technical stuff do they need to know? And oftentimes, if you're an expert, you know, you're a researcher, you're an academic, you know this stuff really well. It's always tempting to kind of get into the weeds, and then you kind of lose the typical MBA. But the response would be, well, look, we have now all this software which will do everything automatically, right? I mean, we have this no code, low code stuff, and now with Gen AI, you could just sort of tell it, hey, just do some analytics for me and tell me what to do, right? And that way you don't need to know anything. I mean, what's the fallacy there? I mean, why is it that you do need
that
to
narrative about
understand
Gen
a
AI
bit?
is pure hype. It's not autonomous. You have to supervise everything that it does. Sometimes it gets it right. Sometimes it gives you a good start, but doesn't remove the need for human expertise. So yeah, the semi-technical level of detail, what's predicted, how well, what's done about it, this is not arcane. This is not getting lost in the weeds at all. If you're a stakeholder in charge of some large-scale operation, like, you know, there's 1 million transactions a month, some of them need to be audited as potentially fraud. We have, you know, a team of 100 fraud investigator humans, right? It's not a huge team. We obviously can't investigate every transaction. There's a need for autonomy to a certain degree. We need to decide, you know, how to use that team. Or we have a limited marketing budget. How many of these prospects do we send a brochure to? Whatever the large scale operation is, if you're the business stakeholder, if you're in charge of that, it's not lost in the weeds to say, hey, look, if we had this pocket of cases that were, let's say, 4 times more likely than average to be fraud, or to respond if we contact with marketing, or to be a broken train wheel if we would only investigate it and avert disaster, whatever that is. Well, that would be a predictive multiplier, 4 times more than average. It still may only be happening 4% if the overall average is 1%, but that's a big difference. And it turns out it makes a huge difference to act on it. What does it mean to act on it? What's that going to do to the bottom line in terms of profit or aggregate savings, cost cutting, whatever, loss reduction? That's just arithmetic. It's not the weeds. It's the absolute central imperative of what you're doing as a business, non-data scientist stakeholder. So I implore thee, right? If you think those are the weeds, then get lost in them, because they're not. They're just sort of the core sensible idea of this large scale operation that you're in charge of. Right. And so
we've seen
token, what your point is well taken, that you hear this all the time about all kinds of new technologies where most of the initiatives fail. But when we're talking about these predictive AI, if you want to call it predictive analytics, these enterprise use cases for machine learning, they do involve a number saying, what are the chances of this particular outcome or behavior? Who's going to click, buy, lie, or die, commit an act of fraud, or whatever? It's a probability. That's what it is. A number between 0 and 1, or 0 and 100, however you want to scale it. What does it mean to act on those numbers, to draw a line and say, well, if it's above this threshold or below, then we decide to do action A versus B, or no action at all? That's the level of detail that you absolutely have to get into. But because it involves probability that so many people tend to shy away from without even trying to get their toe a little bit wet and realizing, oh, this water's not cold at all, that adds complexity, or perceived complexity. So I would say the divide is more challenging with machine learning, getting it in terms of the challenges to getting it deployed than for most technologies.
Yeah, it seems like when we teach data science in academia, we have at Berkeley, we have this whole new school of data science, right? It's a whole new, like, couple $100 million. We're setting this whole thing up. It seems like there are two possible mistakes that are made. One is that the data science is sort of the tip of the iceberg, right? There's all this data engineering, feature engineering, data wrangling, all that kind of stuff that has to happen before you can do the fun stuff, right? And so, ignore that at your peril. But then there's also, I guess, a different iceberg, maybe an upside down iceberg, which is, okay, you've found this model, but then now you've got to figure out how to get people to adopt it. You've got to, find the value in it. I was astonished to see that in most data science classes, they don't even teach first of all, a profit curve, which is the most important curve in my class. But then they don't talk about the human factors. And this is one of the reasons why I love this story.
So the profit curve is the reason we started Gooder AI, and I co-founded it. So profit curve, savings curve, whatever your KPI is, you want to measure how well the model could perform in those business terms. But right now, what happens is data scientists typically evaluate in technical terms, like precision recall, F-score, area under the curve. Even accuracy is only a technical metric. And these metrics only tell you the pure predictive performance. They're good to know. And they show you it's better than guessing, which means it's potentially valuable. So they only tell you the relative performance in comparison to a baseline like random guessing, rather than the absolute business value that you could get if and depending on how you actually deploy the model. That business value must be estimated with best practices, but it's generally not, because if you're not measuring the business value, then you're not pursuing business value. While you're developing the model, how do you know you're navigating in the right direction? And how do you give your stakeholder that visibility? Right now, these projects, it's a shot in the dark. They'll just have this technical metric, and there'll have to be a decision. Well, that's a lot better than guessing, so it should be valuable. It should create a bottom line impact rather. So let's deploy it. And it's sort of like, we can find out later how well it worked or whether it delivered value at all. No. And in fact, because of that scenario, that's not what happens. Instead of shooting in the dark, they don't shoot at all. The stakeholder has to make the difficult decision to kill the project because they're not given that visibility. Right? They don't get this direct estimate of the potential business value of it, just this arcane metric, right? This is, I mean, this is literally what happens routinely over and over again. The data scientist excitedly screams, guess what? We have an area under the receiver operating characteristic curve of 0.83. Isn't that awesome? Yeah. Isn't that all? Okay. So then the stakeholder says, yeah, that sounds good, but then is forced to ask, okay, I'll bite. What's the area under the receiver operating characteristic curve? Of course, the first time you hear the phrase, you might not all memorize it that quickly. So they might say, well, what's that mean? And the data scientist, well, it means it's much better than guessing, which is true and is good to know. And then, well, then what does that mean in terms of the profit of this targeted marketing campaign? Or what does this mean in terms of the cost reduction of better using my fraud detection team, or whatever it is, and whatever KPI pertains? And the data scientists are generally not trained to get into all that business speak. But there's such straightforward measures. I mean, that's the lingua franca of business. So just in terms of, if you've already decided this is the right strategy, let's predict X in order to do Y, right? And that's the first and last of the trio I've been mentioning. What's predicted, how well, what's done about it. The what's predicted and what's done about it, that pair defines the value proposition, the use case, the particular ML application you're pursuing. It's not hard to stumble on a good strategy, but let's do that. Let's greenlight this project. Let's start the number crunching. But once you've done that, you need to, during the execution of it, you need to be keeping the stakeholder in the loop so that they can be deeply collaborating at each step of the project, including the decision of exactly what's predicted, how those predictions are going to be used, and the assessment of how good is it, right? And that's what Gooder AI is. That's what I'm talking about. Let's actually, during that model development process, stress test the model in business terms, in terms of potential deployment scenarios. So that's sort of part and parcel to this disconnect and the lack of being on the same page, putting things on a table that both sides understand, speaking the same language.
Well, I think once you think about it, you realize that organizations are making decisions all the time based on predictions, and oftentimes they do it without expressly articulating what the costs and benefits are, right? So, we think about the coronavirus testing, right? I mean, we talk about sensitivity, we talk about specificity, but how often did anybody actually talk about the cost of a false positive, cost of a false negative, right? Or, if we think about stop and frisk policies, right? I mean, how often did anybody actually articulate the cost of a false positive, cost of a false negative? Or, one of my favorite examples that I use in my classes is the burning of Notre Dame. And so I ask people, like, what caused that? And people are like, oh, faulty smoke detectors, bad user interface, blah, blah, blah. But when you really get down to it, it's that the French government never actually sat down and said, hey, what's the cost of, a false negative versus the cost of a false positive? And so, where should we set our decision boundary? And so I think, once data science is kind of a way to force you to re-examine what it is that like every organization does. And then once you see that, then you strive for, better classifiers, right?
Yeah.
Better predictions.
Right. So that you just put it all out there. So there's really, really good news and then kind of bad news. The good news is that for many business applications, and this is why I'm in the business world rather than healthcare, like my father and other people in my family, it's totally objective. So you don't have to make these tough these tough judgment calls.
Mm-hmm.
You know that a false positive saying, hey, I think this customer is going to buy. So you're going to spend $2 sending them a brochure. That's a very concrete cost. It costs $2, right? So those costs are often super objective. There may be uncertainty and they may be subject to change. So that's another issue. But the bad news is that for many of these cases, the ones such as the ones you mentioned, what's the cost of a false negative versus false positive for a COVID test, right? There is something there. If I mean, we've all been in that situation, or during the pandemic, most of us probably encountered the situation where we're like, well, I could do a test, but the false positive cost is really high. If it says that I have COVID, even though I don't, and I have to change my plans for the next week, that has some cost. It's going to be highly inconvenient. Of course, how do I rate that against the false negative of not discovering I have COVID and going out and spreading it unwittingly, right? So that's totally subjective. Same thing with other medical applications. If the model says you had a heart attack, but you didn't, it scares the bejesus out of you. You're subjected to unnecessary tests, etc., right? The false negative is probably a lot worse. You allow somebody to leave the hospital who just had a heart attack unknowingly, right? How do you literally put a number on the relative of those two? And then, as you said, stop and frisk, right? What does it mean to once again take an underprivileged minority member and subject them to a stop and frisk, right? Unnecessarily, undeservingly. In my opinion, extremely high cost. But again, how do you put the actual numbers relative to the false positive and false negative of all these things? That's really hard. That may be a much more interesting topic for a podcast. Maybe we should talk about that a bit more. But you do have to put a number on it, and whether or not there's subjectivity to it, I'll just say that just drawing that profit curve or whatever the metric is, and so you can navigate and view where you're literally drawing the decision boundary, as you call it, or we call it decision threshold. That's what our solution at Gooder AI does, right? For the first time, nobody's doing that. You need a general solution to be able to sort of configure it according to your use case and your KPIs, be able to change parameters and business inputs, whether they're subjective or not, they're always subject to change. See how it changes the story, that is the shape of that curve, and then move the decision threshold, see how that changes competing KPIs. There's always trade-offs, right? There's other things to consider, right? You might have an overall aggregate savings that you're trying to maximize for your fraud detection model, for example. But you also care about just simply how many times am I inconveniencing a cardholder who's legitimate trying to make a credit card purchase. Obviously not as bad as an illegitimate stop and frisk, extra time in prison or what have you, but still a business consideration. If I'm inconveniencing 200,000 cardholders a month, right? Well, that's an absolute number I also want to consider in the trade-offs. In any case, you need to visualize all this stuff in order to actually stress test the potential business value of a model in business terms rather than only technical terms.
Well, in business school, we use the case study method. And I found the most powerful way to communicate the value of these tools is to bring in practitioners. And of course, you did that with your conferences. And I stole a lot of your speakers for my guy. Jack Levis, I think is one of the heroes of the book. And I had him also come and speak in my class. And in a nutshell, what he was able to do at UPS, I mean, it really does encapsulate a lot of the key lessons that you're trying to communicate in the book. It's just simply not enough to have this wonderful tool. You got to somehow, get buy-in from everybody. So I guess that one of the questions is, why is it so hard to get buy-in? I mean, can't you just say, hey, look, we can add value? Then everybody says, great, that's what we're here for. We're all here to add value. We're all here to, add to the bottom line. So let's do it. Like, why is it so hard to kind of, advance the ball, right, with these projects?
To get buy-in so that it actually gets launched?
Yeah.
Yeah. So, I mean, Jack is the hero of the UPS story, which is sort of the leading story and example in my new book. He also just keynoted for our Machine Learning Week conference once again in early June. And he had to, it was an uphill battle for years. That was overhauling an existing process of improving package deliveries at UPS, right? This is a company that's now more than 100 years old, right? So they're changing operations. Change management's hard. So now change management is a well established discipline, and there's been many books about it. But instead of sort of saying, hey, look, this is how to do change management, my main message is do change management, because that just the basic idea is so often overlooked. Again, we're fetishizing the core technology, more excited about the rocket than its launch, but the launch is change, right? You need to manage that change. The project needs to be reframed. It's not just a technology project. It's not a machine learning project. It's an operations improvement project that uses necessarily machine learning as a core component of it, but ultimately involves the improvement, that is to say, the change. The operations don't improve if they don't change. So sort of taking the project with that reframing and recognizing, okay, we're going to really be changing our largest scale operation on a daily, hourly, minute by minute practice, or on a minute by minute basis. That's a big change. And if you recognize that's what it is, not just the core number crunching, that's the coolest rocket science. That's the fun part from a scientific vantage. It's the most complex mathematically at the core of it. But it's not the focus. The focus has got to be how those predictions are going to be changing the operation. So yeah, we are routinely continuing to repeat that mistake. And in a way, it can be like, well, why can't people realize it? But again, I think that right now it's just about the incentives catching up. Right now, hype is self-propelling, and the hype hasn't been helped. The hype problem has not been helped by the advent of generative AI. Now, generative AI is the most amazing thing I've ever seen in my life, but that's the problem, right? A great demo doesn't necessarily mean valuable. Right. I think it's probably about 5% as valuable as the world seems to think. Right. So, I mean, I spent 6 years in the natural language processing research group at Columbia, where I was subsequently a professor during grad school. I never thought I'd see what I can see today, but we need to recognize there's a big difference between something that's seemingly human-like and a human.
Well, I mean, shouldn't the hype help? I mean, you said that, it doesn't make sense to talk about your machine learning strategy or your AI strategy. I mean, of course, this is what every single CEO is asking their CIO right now, or it's like, hey, what's our AI strategy? And you say that's not a good way, not a good idea. But I would expect that in today's world, if you have some idea for operational improvements, that if you wrap it in some AI hype, this will actually help the pill go down better.
Well, it gets triggered, right? It gets the project triggered, doesn't necessarily help get deployed, because again, the hype's about the technology rather than the actual change that would actually mean the realization of value. And it helps with fundraising. So, I mean, so let's unpack that. Shouldn't the hype help, right? It generates momentum and it helps in a certain way. But I think that overall, if we define hype as the same thing as overhype, right? If we define hype as a mismanagement of expectations, if we define hype as overpromising, right, then ultimately it hurts more than it helps. And in particular, it only adds fuel to this syndrome, right, which is that we're fetishizing the core technology rather than the realization of value, the improvement to operations in a very concrete sense that may well be served by this technology or that technology. But it's solutionism, right? I mean, that's what the AI hype is all about. To a hammer, the whole world is nails, right? Mm-hmm. Everything can be solved with AI. No, well, everything could be solved with an artificial human, right? And that's what they call that. That's what I call AGI. So AGI is the underlying narrative that underlies most of the AI hype in one way or another. Artificial general intelligence, a computer capable of anything a human can do, and it can run a Fortune 500 company or be your ultimate virtual assistant or whatever. It can do, you can onboard it like a human employee and just let it rip. It's fully autonomous because it can do whatever a person can do, which also means it can do whatever a person does, and only costs electricity. It doesn't ever get tired or need to sleep or make mistakes the way humans can. And it scales across CPUs or GPUs, as may be the case. And it can self-improve because it can conduct AI research the same as a human. And then the Skynet's the limit, right? So that narrative is a ghost story. we don't have artificial humans, and I don't believe that we're concretely headed in that direction. I don't mean that they're theoretically impossible, but I think that the narrative is so fueled because large language models are uncanny. They're so seemingly human-like, but there's a much bigger divide between what they're capable of and what humans are than we're giving ourselves credit for.
Well, look, there are a lot of organizations that are really barely scratching the surface in terms of their utilization of these tools for business improvement. I mean, I'm at a university. I mean, we don't even do the basic analytics on our alums to figure out who we should be admitting, right? I mean, this is, basic customer type research. And so if you're trying to kind of get the organizations to do this, I mean, can you do it from the bottom up, or does it have to be top down? And I guess a corollary to that is, a lot of people that I spoke to who were trying to do this in organizations, they would go for some quick wins and then get buy-in and then expand their budget and do a little more and a little more. And I guess sometimes this is referred to as, lean machine learning, right? Lean approach. But sometimes you need to have like a high upfront fixed cost to kind of get all the data in a format that you can actually use. So, are there going to be situations where you can do baby steps and maybe do it from, the bottom up or the middle out? Or are there going to be situations where you have to do it top down and you need to have these upfront fixed costs?
No, I'm pretty agnostic about whether it has to be top down, bottom up. I think that the change isn't about where the project, how it's conceived and where it originated from, but rather how it's executed, and it's a paradigm shift, right? And the paradigm shift is that there needs to be deep collaboration between the two sides, and there does really tend to be two sides. Most people, almost all people, are much more heavily from a technical versus business or quantitative versus stakeholder background, or at least their role is going to be one or the other. So we do have this kind of bifurcated population who need to collaborate very deeply. I mean, even if you have a highly technical background, when you're actually doing the model development, the number crunching, you're prepping the data and running the machine learning software, it's almost impossible not to lose the forest for the trees. You need that other party who's focused on the business to keep you in check, in a sense, and keep the contextualize everything you're doing. So if they're playing more of the business stakeholder side, right, you need that collaboration between the two sides. It's collaboration needs to be deep. It needs to be both pre-production, post-production. It can be agile. You can do some number crunching off the cuff. You can do a rough data pull, and that's fine. But you have to realize you're not necessarily moving towards business value until you've adapted the more holistic business practice. In the book, I call it BizML, the business practice for running machine learning projects. And that's the domain's website for the book, bizml.com. So that's the 6-step practice. What we've been talking about today is more about this idea of semi-technical understanding, which is the bigger message, is the more important fundamental paradigm shift that needs to take place. But then everybody needs to understand, hey, there's some number of steps that involve that semi-technical level of detail, where we meet between the two sides and where there's deep collaboration from end to end through to actual deployment, and then monitoring the project after it's deployed to ensure that it continues to deliver value, keep it, manage it, maintain it. Another way to think about this paradigm shift is that it's reverse planning. You're starting with that deployment goal. You're starting with a concrete, specific value proposition. And ultimately, whether we're talking about predictive AI or generative AI, that's the antidote to hype. It's a focus on specific, concrete use cases, how exactly it's going to realize value, what operations are going to be changed, improved, or driven by what exact use of technology. So how do we, excuse me, how do we get to that value, to that deployment?
And so who are the folks in the companies now that are, I mean, are we seeing this rise to the level of a typical CEO, or a typical CEO is going to be familiar with?
Sorry.
Sorry.
Can we edit this part out?
Yeah, of course.
I normally have a coffee. So
take,
I'm
take,
talking out of cough drop, and it'll go away in about 30 seconds.
take your time. Take your
But
time.
so I just got over strep throat.
Oh, all right. That sucks.
Well,
Um,
it's not actually that bad because once you get diagnosed, you get the antibiotics, right? It's
oh, okay.
much better than a
Yeah, it's a
virus.
simple. I didn't know. It's a bacterial. It's not a viral thing then.
I thought
Strep throat.
everyone had strep throat at least a few times. You never had strep throat?
Not to my knowledge. Maybe I just never went and got
Wow.
it diagnosed as
Well,
such.
you probably would eventually. And if it's left untreated, it gets really bad. But
Oh, okay.
it's
Probably
a very
buzzing around.
particular kind of sore throat that hurts really hard.
Yeah. I'm sorry about that. But
No, it's fine.
anyway. So all right. Well, I'll ask the question, and you can
Yeah, thank you.
answer. You can take it away. So, when we think about the semi-technical knowledge, how far up do you think it needs to go? I mean, I do a lot of time. I spend a lot of time talking to executives, and when you think about things like APIs. I mean, I remember 20 years ago, typical CEO couldn't spell API, right? And typical CEO wouldn't be familiar with terms like overfitting or data leakage or whatever. Um, do you find that CEOs need to know this stuff, or is it okay if you got people at the at the operations level that are, and marketing folks that are familiar with this semi-technical material?
No, it's more for operational. But I mean, the fact is, it's so straightforward. I mean, it's very easy to imagine a CEO talking to the operations person, to the VP of some line of business, and saying, "Oh, well, what are you doing with this fraud? How bad is fraud? How much is it costing us? How many transactions?"
Mm-hmm.
And then just looking at five numbers of this is how often fraud happens. This is how much it costs. This is how big our team is. This is how many transactions they can audit. This is how we decided which ones to audit using machine learning. This is how much better than guessing, right? It's like five numbers, right?
Mm-hmm.
But the difference between the CEO and the person and the business side stakeholder who's sort of in charge of those operations is that the CEO can sit down and have that meeting and see those numbers and maybe ask some basic questions and totally get it. But they're only going to spend 20 minutes on it twice a year. So it's not going to be at the tip of their tongue. They're not going to be dealing with that level of detail. It's not going to stick in their head pervasively because they're not operating with it, right? So I think providing that visibility is valuable right up to the very top. And of course, the smaller the company, the more likely they are to be involved in. Great, but I'm talking about let's say Fortune 500. I don't. This is sort of outside of their purview in general.
Mm-hmm. Well, I like to think of technology as flowing like water, right? I mean, the minute something is invented in Silicon Valley, somebody in Cambodia is going to have access to that tool, within a matter of minutes, right? So that you can be in the most remote part of the Himalayas and you can still get ChatGPT on your phone, right?
Yeah.
But the part that's really hard are the business practices. These things are diffuse much more slowly, and there are companies like Google that utilize these techniques, very effectively, and so I think that the biz ML method that you have here is about how to start implementing it, but you can apply it to pretty much any kind of new technology, right? Any kind of new technology, you need to have a process for implementing, executing, and deploying. Do you think that 10 years from now, you're going to have to write another book, sort of reminding people again, like, hey, you need to have a process for incorporating technology
No.
into the business?
I think I covered the fundamentals, but I think you just made a good argument for me not to create an updated edition, to wait a decade before I do so, because this message will still be pertinent, and that's the best way to get it back out there, is the revised edition. So maybe I should wait until then, because there'll still need to be some repetition. But yeah, I mean, just sort of reflect back the way you just put it. Yeah, there's always going to be a new operational issue and business practice framework for any new technology. The difference here is twofold. One is it involves probabilities. So we just have this real shying away from any details, even though they're super accessible once you dip your toe in combination with the anthropomorphizing hype that engenders solutionism, where it
Mm-hmm.
becomes intrinsically valuable, but it's not. It's only valuable depending on how you use it to change and thereby improve operations. So those two prongs are continuing to keep us down. We're being held
Mm-hmm.
back here, man. So we can change it, and it will change eventually because the incentives are coming, right? I mean, there'll be disillusionment. There may even be another AI winner. And one way or another, look, if we're going to improve a large scale operation, you do it with prediction. If you want to do large scale prediction, one prediction per case, that's machine learning. So, but we have to actually get it deployed. So there's a lot of incentive to do that. And even if there's disincentives that I've been mentioning, they're going to continue to get chipped away as we focus on value. And so there'll be a shift, and it'll become more commonplace for the business side to get involved in that level of detail a bit more. And a lot of business people, I think right now, like, well, I know you have to start with the business value. And yes, we're going to target marketing with predicting purchases. We're going to target fraud detection by predicting fraud. Whatever it is, they have that basic idea, that value proposition, the pair, what's predicted and what's done about it. But that's literally only the first of the 6 steps of BizML, right? So what is not yet pervasively understood is that level of detailed involvement needs to be prolonged and deeper across more aspects of the project. But again, it's not the rocket science part; it's just steering the rocket.
Well, last question. Look, business people have to continually update their software, right? Their human software. They have to learn new skills. They have to learn new approaches. And there's a couple different ways to do it. I mean, one is executive education, right, which universities are known for and good at. Another is to go to these conferences like the ones that you organize. And I that's one way that I go to kind of refresh is to go to these kind of industry conferences, trade conferences. And then of course there's, just picking up a book or, listening to a podcast and so forth. What are the costs and benefits of those? I mean, when you created your conference, how did you see that fitting into the kind of upskilling, reskilling of executives? I mean, how does something like that compare to sort of like an executive education approach? I mean, are they substitutes? Are they complements? How do you see that?
You cut off there. Are they substitutes?
Okay. I was asking you about, executive education versus conferences. How do
Right.
you see them
I
as
think I got the
substitutes or
point. It just stopped after the word substitute, but
Yeah.
I think I got the question. Um, yeah, no, I think that a conference is not really a substitute for a course, but it's very valuable to do both. And in fact, so I've been running the conferences since 2009, and that's always been the intention, is to bridge that gap. Unlike most data science conferences, we're not just catering to the hands-on quants and techies and data scientists. We even have a full track devoted to the business slash operationalization, BizML side of things. So we have a much higher proportion, even though we're still mostly data scientists, and a lot of the sessions are very technical. At Machine Learning Week, we've got business focused, and that ends up being where we have the most interested speakers for that track, and often the most seats filled in the room for many of those sessions. And as well as our plenary sessions tend to focus on that level. At the conference, we have full day training workshops on the days before and sometimes after the 2-day main event itself. So I have an online course at machinelearning.courses, which the contents of which are it kind of extends beyond my 2 books to a certain degree. But yeah, it's a kind of upskilling. And I think that you need both. You want to get out there in the field, see what other people are doing, and have that shared experience at a conference, but you also need to kind of get the basics. And just to be clear, if I'm saying, hey, look, the world needs this semi-technical understanding, that's the main contribution of my new book. It's meant to ramp up the non-technical newcomer reader. I also make a case early in the book of why, if you're a data scientist, you should also read this book, especially
Mm-hmm.
chapters X, Y, and Z, and then give it to your boss. But first and foremost, this is for business readers to ramp up on those very skills that are needed so that they can then effectively participate in the projects.
Yeah, and there are no formulas in the book, and there's nothing in there about backprop or anything like that. So check it out. It's called the AI Playbook, and also the old predictive analytics book, I think, is still in print, right?
You cut off after check it out. It's called the AI Playbook.
Yeah, and then I said the predictive analytics book is still in print, right?
Oh, yeah. Yeah, the predictive analytics has been adopted by hundreds of universities as a textbook, even though it reads as a sort of pop science. Same thing with the new book. It's accessible. They both provide background information, neither is a prerequisite for the other. And thank you for plugging the book. That's very nice of you.
Well, I appreciate it, Eric. Great chatting again, and hope to see you again soon.
Yeah, likewise. Thanks, Greg.
Unsiloed podcast is produced by University FM, elevating the stories of your institution.